I come to project number 30, and that is aspects of automated testing, and it is a very large project. We have a lot of activities. So first, test case selection, where we try to run only the most diverse cases, and that helps in speeding up the continuous integration flow a lot because we don't test everything all the time. Flaky test is a bottleneck where we have been working on both detection and mitigation. We will put a lot of work there next sprint, I hope. Test case generation is compare the human way of designing test cases with combinatorics. It's quite rare that humans think of all things that can go wrong in combinations. We also will start a new activity in test parallelization, where we'll have faster tests by testing in parallel. But there are a lot of conditions that have to be fulfilled. We get efficient feedback and hardware utilization, tear down routines and other things. The team is quite large. From Linköping University, we have Mia Asim, is involved here as well, and Ola. Chalmers Gothenburg University is Francisco, who will present later, and Greg. And at MBH, we have worked a lot with Eddie, and we have had started a very good contact with Sean Malm and Björn Lisper, and they have been finishing off some interesting thing in the TESTOMAT project, and we would be very glad to do more than just exchange, but work together in next sprint. That will be a huge effort beating the flaky test curves. The agenda today is, I just want to give Sean Malm an opportunity to say hello. So he will present himself and some of the research in a very few minutes. Then we will spend the rest of this talk to behavior diversity-based testing, and Francisco will lead us through that. And with that word, I leave over to Sean.
Thank you, Kristian, for the nice introduction. Should I run the presentation myself, or?
Oh, sorry. Yes, can be prepared much better. I of course run it then. I share the screen again.
Because I have so few slides, I think I can just ask you to.
Yeah.
Yeah. So hi everyone. My name is Sean Malm. I'm an MDH PhD student, and yeah, I have a number of research interests. So I started in static code analysis and timing analysis. I was working with Björn Lisper on the suite tool a bit for my bachelor and master thesis, and recently I have also started looking into flakiness, test flakiness related to timing issues, because those tend to consist of a large amount of the flakiness that are identified in academia, for example. And as Kristian mentioned, I am currently part of the TESTOMAT project, which is in the wrap-up phase. We actually had we started the end game process today before this software center meeting. If you can go to the next slide, please. So my work in TESTOMAT primarily consisted of a tool. I made a tool for extracting delays in test code. So to handle specific type of flakiness issues, developers insert these kind of delays. So what my tool tries to do is to classify these delays, but I'm also interested in what kind of durations, because especially in when you're using simulators and that kind of thing, you can these delay durations can actually add up and cause inefficiencies in the test execution. So we have a small visualization for that as well. Next slide, please. And my plans, if I end up being able to join Software Center, would be to continue the work started in TESTOMAT. So, for example, explore different kind of program analysis techniques for detecting flakiness. I am currently looking into taint analysis for this thing, and also I'm interested in applying some timing analysis for flakiness mitigation. For instance, making these delays more efficient. So that's a short overview of me. And thank you for the opportunity. And if there are any questions, you can contact me.
So thank you very much indeed. And you will work together with Asim, and he has done also some tool development that is soon be finished. But now I leave the word to Francisco, who is the main speaker of the project, and he will talk about some recent findings in diversity-based testing.
Yes, thank you, Kristian. So can everyone see my screen?
Yes.
Okay, awesome. So thank you everyone for attending this part. Also thank you for Kristian and Jam for kicking up the presentation. It's a lot of presentation, so I'll hijack a little bit of Birgit's presentation this morning. Try to do a little breathing now, since we're switching a lot between different projects, so that you can perhaps survive one more presentation. So yeah, as Kristian said, I'm Francisco. I've been part of this big project in Software Center, in which we contribute to the best of our automated testing so many different ways. So I'm going to discuss I'm going to focus in one of our contributions, which is to improve test effectiveness via selective testing, and I'll explain a little bit more about that. So don't worry. I know there are some unknown terms here for many of you perhaps in this title, so I intend to explain what the hell is diversity testing, and then not only that, then you throw in behavioral, Francisco, what the hell? So I'll go through all of these points so you can try and understand more the type of work that we do, and also if you're interested in joining our initiative, how can you do it? Okay, so just a few of the pointers. Whoop. Okay, so yeah, next slide. So what will it talk? So I'll explain the what, why, and how about the technique. I think those are the main points that I want companies to understand a little better, so that they can see if it's something that they're interested in. And I'm going to present the current results that we've had about improvement on test effectiveness by doing less tests. It's not about testing less necessarily, but we want to test in a smarter way. So what type of problem do you intend to solve, Francisco? So it's a very typical testing problem. It's not a new problem. It's a situation where you have a prohibitive testing scenario. And what does that mean? It basically means that you cannot test everything. You have to make some type of decision on what you test for various reasons. Either you have too many tests, either you have very few resources. Regardless, what you want is to maximize the effectiveness of tests while minimizing resources. Now with continuous integration, most of these resources, they are time, because usually now with regression testing, all of the different tests accumulate, and then it's more and more difficult to run all tests in a reasonable amount of time for you to not hinder your feedback cycles. So then testing becomes slower and slower. So we want to find ways to make this test better, so that we can have shorter cycles. We can keep the testing cycle shorter, but we don't lose information by testing less. So it's a typical optimization problem, and usually the two main variables that we want to optimize here, if I can find my, oops, it's basically, so the two things that we want to optimize is coverage and failure detection. So I can't see my pointer, but we'll play with this. So this is not, as I said, this is not a new problem. It's been investigated for many years. I would say there's a catalog for over 200 different techniques that you can use on how to choose tests using various types of information. We focus on one, and that's the diversity-based techniques. So diversity-based testing is kind of like a family of techniques that cover how to be selective on testing. And why do we choose this? Well, because over and over, when we look at testers, if you give them the option and if you ask them, you don't have time to execute everything, what are you going to choose? They usually go for choosing the most different tests. So the tests who are diverse from one another, such that if you don't have time to cover everything, then you might as well cover a little bit of everything else, like a little bit of everything. So usually people go for breadth over depth. And this is what we call diverse. It's something that has a big spread in terms of how they are different from one another. So that is a very generic idea, because what do you mean by diversity, Francisco? Well, it can mean very different things. In fact, you can find and be selective by executing fewer test cases that cover, for instance, a diverse set of requirements. So you want to cover the most different requirements. You can also cover a diverse set of test statements, like assertions. So you can try and see which assertions are different than one another. A diverse set of test input. So you don't want to test, for instance, the same input the many times. You want to test different set of input values. So as you see, like I use diverse in different contexts, and the underlying idea here is that you choose things who are different from one another. And specifically, we are focusing on behavior. And what do you mean by behavioral diversity, Francisco? Well, I mean that we want to select test cases who have different behavior, meaning that they trigger different parts of the system under test. Because if you don't have time to execute everything, you want to make sure that you've covered the different parts of the code where the bugs could be hidden. And how do we do this? So I'll try to explain this via a simple example. Imagine that you have here a very familiar picture. Sorry that it's not colorblind friendly, but it's a testing culture that we use red and green. So imagine that this is a test history. I think if you run Jenkins or any CI pipeline, you have a similar picture like that, where in the rows you have each test case. So here I have 4 test cases, and I've executed these test cases in 6 different builds of my system. And throughout these builds, like historically, some test case pass and some test case fail. If you look closely at these 4 test cases and the 6 builds, I would like to highlight a few things. So if you look at test case 1 and 3, look at 1 and 3. If you focus there, you'll see that they consistently have the same outcome. Whenever they run together, either they pass together or they fail together. So that is an indication that they have very similar behavior. But if you compare test case 1 and 2 there, they have very different outcomes. So not every time they pass together, but they rarely fail together. So if they are going to review bugs in different parts of the system, perhaps that's because they actually cover different parts of the system. So this would be an example where if you don't have time to execute all 4 test cases, if you can only pick 2, you wouldn't necessarily gain anything by running 1 and 3. Instead, you'd like to run, for instance, 1 and 2. Note that all test cases here, with the exception of 4, they review 2 failures. So you really want to be smart on when did these failures occur in history and how do you capture this behavioral diversity. So whenever we talk about why do we do this, it's because, as I said, like if you don't have time, you want to make sure that you run test cases who are less likely to fail together, because that indicates that they may be redundant. Of course, you want as many failures as possible, but sometimes a chunk of test cases can fail because of a single bug. And if you just have one failure and you fix that bug earlier, all of the other test cases will not fail again. So what you really want is to trigger the different parts of the system to review different bugs. And as I said, like this is mainly an assumption, because that's one of the things that we use mainly being a black box testing technique. So this is black box, meaning that we don't look at the code necessarily. So on one hand, we start to make these assumptions about the system under test. But on the other hand, we cut off completely the dependency to have our testing and test decisions being made based on what you modified or which coverage you get from the source code. So it's a trade-off, basically. But I would say based on our initial results, this trade-off really pays off, because we've been able to improve test effectiveness just by looking at the co-execution of the tests. So how do we do it? Basically, this is the standard pipeline. You'd have something that runs from engineers. They submit a modification. A CI pipeline will run a massive test repository that may take hours to run in a system under test. And what we propose is to create like an add-on. So it would be this second track here, where once you trigger your CI pipeline, you can actually run our diversity-based optimization test suite, we have several techniques, including diversity, that will look at your test repository and select an optimized subset of tests. Okay, so the benefit is that you can end up executing much fewer tests. Not only that, we want to see this diversity measure and then trying to understand how your test repository is. Are you creating very redundant test cases? Are there test cases who are obsolete and have not been used? So we try to compile all of this information into some type of analytics toolkit that can offer this information back to engineers, and they can help them maintain the test. So I would say the results that I'll present mainly now is by running an optimized subset of test suites in the system under test. So if you don't have time to execute all test cases, what if you execute fewer test cases? How much on failures are you still revealing? Of course, you're only going to reveal as much as they all. So I cannot reveal more failures by executing fewer tests. It's impossible. But the important thing is perhaps if the chunk of test cases that I did not execute, if they didn't add any value of revealing new failures, then you actually gained in time and resources. So I'll show the results from two companies that we've worked on. So this is company A. We received from them a massive test history. So that's the picture here on the right, which is a much bigger version from that first one that I had. So of course, Francisco, with 4 test cases, we can look at it very clearly and find these patterns. Yeah, but try now to do it with 4,620 test cases and like thousands of builds. Then we need to automate it, and that's what our tool does. So basically, we went through this history and we started to find the patterns of the different test behaviors, tests that co-execute together and show similar outcome. And we said that we would focus on executing test cases who have these different patterns, and it was very successful actually. We ended up becoming like being able to review 90% of the failures by only executing 40% of the tests. That's less than half. And since this is a test execution that takes hours, so now they don't need hours to review the same amount of failures. And then we can actually highlight and find the test cases that fail earlier. So, and if you make the math here, so it's 40% out of 4,000. So it's still a good increase, like a good savings. One thing that you should note here is that this picture to the right here has a lot of gray parts, which means that it's test execution data that's missing. So the test case was not run on a certain build. And sometimes that happens for various reasons. It's not necessarily a bad thing. What we thought it was interesting is that regardless of these holes that we have in the data, our technique was still really good at performing. Of finding good failures. So I would say that it's quite robust. Of course, like in our current state, we see that the more field your history is, the better the technique performs. And that leads me to company B, which is the second one that we've run. So this is a different company with a different test history that you can see here for the right. So now it's a complete one. So they've ran all test cases on all versions. And then already by looking at this picture, we can see some interesting patterns, which I highlighted here in the dashed purple box. So you can see, for instance, this first one is the top is a classic case of 2 test cases, several test cases, not only 2, it's several rows there. So each row is a test case again. So several test cases who are consistently showing the same outcome. So perhaps you only need to execute 1 out of all of those. And then in the bottom there, you have somewhat of a slash like diverse and also slash is a similar behavior for some test cases where you can see some of the columns they fill together, but some other test cases don't. So I would say, like, if I were to tell the company to be selective, focus on those test cases in the bottom, because there you can have more, not only unpredictable outcomes, but more of a variance of different outcomes. So this one was a smaller test suite, which will with 1,000 test cases, 1,011 as it shows here, but it was also very long because this is also a system that takes hours to run all test cases. And with the results, we noticed that with only 10% of the tests, we could review all failures. So our technique basically outputted like a set of test cases ranked. These are the ones that you should execute at first. And if you take only the top 10% one, and if you just run that, then you could actually find all of the failures for that build. So that was very impressive results. So what you should take away from that, what is the main lessons learned here? I would say this is not new. So we've been using diversity-based testing for different sprints now. I would say we've been using them focusing on the content of the tests. So we look at actual textual diversity, and our previous result has shown really good improvement in coverage. So we could cover a lot of the different features of the system with fewer tests. But now, and this is the new part of the new outcome of this sprint, now we look at this behavioral diversity that actually helps revealing failures earlier. So you don't need to run all test cases if you want to reveal more failures. I would say one really great asset of this technique is, if you compare to many others out there, is that we don't need or look anything at the code level. So as you may see there, the only information that I used as input for the technique to run was that green and red picture by the shown on the right, which is a test history. That's the only thing that we need. We don't need change functions. We don't need your code. We don't need function names. We don't need anything. That's the only thing that we need is the test history and the test behavior. One of the clear limitations is that if this is your input, you're only going to get good results if you have a consistent test history. So for projects who are very young and don't have that many builds yet, or if you have a lot of missing execution, let's say if you only on average run 30% of your tests, meaning that you have 70% of your picture is blank, then the technique starts to lose performance, and then we would advise you to use something else. But I would say CI pipelines currently help a lot in creating more consistent data sets to use these types of techniques. So you may be thinking, Francisco, that's awesome, great, I agree, of course, but I'm biased. So before I go into how you can help me, and I can help you in assessing your test activities, I would just like to go back to the first slide to see if I've covered and I've answered the questions that I set out to answer. So what is diversity-based testing? I would say like it's a family of techniques that identify similar tests. Specifically, if we look at behavior, we look at the different behaviors of the test suite when we run them into different versions of the set. Why and how? So, well, because it identifies test cases that likely cover different parts of the set. And then how do we use it? We connect it with CI pipeline. So can it improve test effectiveness? Yes, I would say we got very impressive results where we reveal definitely more of the failures with fewer tests. And if you're wondering how can you help us, like, and how can we help you? If you're curious about if you can achieve more effective testing, contact. Well, I put in my mail there, but you can also contact anyone in the project. We all work together. So Kristian, Greg, Azim, like all of us, we're working together in these techniques, and you can send us data. The only thing that we would need is a test case ID, the build ID, and if the test case passed or failed. We don't need the test name. You can send TC1, TC7. You can send ABX. We don't care. The only thing is that we would be able to map the ID of a test case to one of the build executions. So if you can send us that, we can tell you how much you can save on your testing activities. That's it. I make myself available for questions if you have any.
Yeah, thank you very much. You got one question from the chat.
Okay.
How do you choose between two test cases with similar outcome?
So that's a great question. So let's say that two test cases are equally similar. So how do you choose between them? So there are several different approaches. There isn't a right one. The one that we currently do is random, basically. And it hasn't changed much. Of course, if we need to make a more sound decision, which is what we want, it's the part where we look at the analytics part of our pipeline. So for instance, then we would need to ask the company, okay, what makes this, if you would have these two test cases, what would make you choose one over the other? Is it perhaps because they cover a more important feature? Is it because perhaps they have failed the most? So there are all of these different properties. Currently, we use random, but of course, like our long-term goal is to perhaps allow like a toolkit that people can select. Okay, in a tie between similarities, you can prioritize these test cases who are more relevant as opposed to these others. So yeah, short answer, currently random.
So is there yet another question for Francisco or Sean? No, in that case, I thank you both with a distributed applause.